Hi guys, Mal here, Mal back. Basically I had another breakthrough with the system in regards to energy efficiency, and I was going through some old Don Smith documents that a few people provided for me, very in detail. And I'll probably be adding some of that to the PDF guide I'm writing. It's going to be a very detailed PDF guide how to construct these systems. And basically, we're on the verge of creating self-sustaining wireless power systems. And basically, there's no doubt it can be done, because if you get the most updated version of ChatGPT, you can literally ask it, is it possible to build a self-sustaining wireless power system that once started runs itself while also generating excess power via resonant receiver coils? And it always says yes. And there's nothing magical about it, how it breaks the laws of physics. And the reason why it works is because you want your receiver coil to have a higher Q than your transmitter coil. But that being said, you want to construct your transmitter with the highest Q possible anyway. And what seems to be occurring is you need all these parts for it to function correctly. You need a primary coil that's 8 gauge. It can't be anything else. And when it's a quarter of the size of the secondary, it seems to be the most energy efficient. So we have 8 gauge here. The secondary can be 18 AWG or 20 AWG, and I was using gold laced, very thin layer gold coated magnet wire. Little pricey, but it's worth it for the extra effects. It'll save you about a little over 1 watt of power on the transmitter's consumption. And the important thing to note is the primary and the secondary are both wound in the same direction. It has to be the same direction, or it won't work. And it's just a modified Slayer circuit. That's just a resonant cap for efficiency. And this coil, this is very important. This extra coil and the ball. The extra coil, I believe, is what's doing all the work for the magical effects. And the extra coil is wound counterclockwise from the primary and secondary. So, same direction, counterclockwise. And the ball antenna, very important. You need the ball to radiate the power. This is the dielectric ball antenna that radiates the wireless power that you create with your counterclockwise bucking coil. So, and this is 2 inches long. So we have 1 inch long, 4 inch long, 2 inch long. And your ball, you can either use a 2 inch diameter ball, 4 inch, 6 inch, or 8 inch. All your measurements and wire lengths are divisibles or multiples of each other. If you build the system too big, it won't function correctly. If you build it too small, it won't work correctly. So again, L1 primary coil, 8 gauge, 1 inch long, 4 turns. L2, I don't even bother counting it. I just go by 4 inches long on a 2 inch diameter PVC pipe. This coil can be 18 gauge or 20. Mine is 18. The L3, 18 AWG wire. Same thickness. Counterclockwise. And then just the ball, which is series connected to it. It's just taped. This is my experimental model. Everything is fully modular on it. You can take it apart. And to really improve the energy efficiency, you need these special diodes coming off of the L1, because it prevents detuning. See how these diodes are almost they're coming right off the L1. They prevent detuning. And the more of these you add in series will increase the energy efficiency, but you'll also lose wireless power effects while improving energy efficiency. The resonant capacitor is what will improve your energy efficiency while simultaneously increasing your wireless power effects. So you really got to strike a balance between energy efficiency and wireless power transfer capabilities. But anyway, the most interesting thing I wanted to show you is, as you see, there's nothing in here, nothing hidden. This is a resonant receiver coil, constructed identical to the transmitter, and your resonant receiver coils are always constructed identical to the transmitter, minus the ball. I don't know why not having the ball makes it work so well, but it just does. And then you just put a bridge rectifier on the primary. That's very important. That's where all the power comes from. And the bridge rectifier is it's made out of these diodes. I think they're 1N5819. I'll link them in the description of this video. So basically what happens that's interesting is you can get more power. You can get excess power in the system from resonant receiver coils. Or, this is the really weird thing, you can literally connect this is a dead outlet. I just connect it to the ground here. You can see how the ground screw is right there. I literally connect this to the ground. So that's connected to the ground. And this is the really weird thing. When the transmitter is powered on at about 2 or 3 watts of power, the transmitter can be powered on, consuming 2 or 3 watts of power. And if you place a bridge rectifier in series, like in the line between the ground connection, you'll get an output. The bridge rectifier will put an output of like 40 volts at anywhere from 20 to 50 milliamps. And you can keep repeating that circuit, and you can stack it to get to the point where you get 3 to 4 times your output power than input power. And I don't know how that effect occurs. I don't know why that effect occurs, but it's almost like somehow the transmitter is producing shockwave type energy that once it's on, it almost is like it's drawing power into itself from ground connections. It's really weird, but very interesting and beneficial. And the way you would do it is you literally, like, this is the bridge rectifier. You can see how the AC side is, you would just basically run this, you would just put the bridge rectifier, the AC side, in series in the line. So you would literally just put the bridge rectifier here, one AC side going that way, one AC side going that way, and you would have DC output. The bridge rectifier literally is installed in the line of your ground connection, which is weird. And it outputs power, and you can keep duplicating that circuit. And I found you can take a antenna cut to a quarter of the wavelength of what the transmitter gives off, and you can again put a bridge rectifier in series in the line between the antenna and a ground connection, and you get power that way. And again, that's a separate open system from the transmitter, so you're independent of it and you're getting more power that way. And this is the crazy thing. So I'm going to explain what's going on. I turn the DC power supply that runs the transmitter. We're using 3 watts. Transmitter is consuming 24 volts, 112 milliamps at less than 3 watts. And I have 2 of those grounded receiver rectifier circuits, and their power output is combined with the resonant receiver coil, and it's powering up this DC to DC boost module. And this thing will now output, it outputs pretty decent power. It outputs much more than it's consuming. About 5 watts now this will output. And while it's doing that, you also still have wireless power, which should be impossible. So I will short these leads out. And as you can see, we have power here. The weird thing is too, the more wireless load you put on this system, the less power the transmitter will consume. So this is shorted out. There can be no doubt this is shorted out. And when it's shorted out, the board shuts off, the red light goes off. So this is shorted out. And keep in mind this is shorted out. It's a dead short. And the power consumption dropped. And we also still somehow have wireless power. At very good range, at 3 watts. Like, that shouldn't even be possible. So keep in mind, that output is shorted out. That output is shorted out. And I can take these little wireless receivers, and touch it to anything metal, and we still have phenomenal output. This was the older model of the transmitter. It's not connected to anything, it just sits right here. It's where it lives, and he still outputs too. He's acting as a receiver. Look at that, just get him near it and it glows. This extra coil is what's doing all the work. So I'll show you even more phenomenal effects. Again, we're consuming less than 3 watts. The output of my combined resonant receiver coil and earth energy extraction circuits are shorted out. And I can take this, and we still have phenomenal ground current effects occurring. Like, look at this. This transmitter is conjuring energy out of the earth. It's sucking power towards itself from the earth. And this is just a 10mm white LED light with 2 RF version of the 1N4148 diodes in a pigtail configuration. You grab the back and you touch it to anything and it lights up. Look at that. Really interesting, huh? See if it shows up here. Yeah, it's brighter up here. How weird is that? From a 3-watt transmitter is doing that? That should be impossible. So the energy efficiency effects of this transmitter are almost at the impossible levels. And the reason for it is the extremely high Q that it has. And certain metals just absolutely magnify this type of radiant energy. So this is just a thermos. I believe it's stainless steel. This is just an antenna wire. Connects to one of the rectifiers. As you can see, there's nothing hidden in the toolbox. There's nothing under the table. I have people telling me I'm faking stuff, but I'm sorry. I've devoted years of my life to this work. Nothing is faked. And this is going to be kind of a long, lengthy video where I'm going to talk about everything, how it works, demonstrate it, and show you basically everything that's going on in a nice, neat way. So, this outlet is electrically dead. We're only extracting ground power from it. So keep in mind the transmitter is on, consuming less than 3 watts of power, and if I even bring this near the ground connection, it lights up. So we're obviously extracting ground power, a lot of it. Look at that. And to show you there's nothing weird or funny going on, I'll touch this ground lead and all this. Like, I'm not getting shocked because it's a dead outlet. And I'll show it's dead by putting my meter in it. So we'll switch the meter to AC. And this is a completely dead outlet. As you see, there's no voltage there. It's a dead outlet. Because this is an old farmhouse. When we bought the house, the wiring was screwed up, and the only outlet that works, we had to run a new one. The only outlets that work is just one outlet behind that crate I put my feet up on, and it's just one 15 amp outlet that works. And from there, there's like a power bus bar that everything extends to. And I have an extension cord that runs down along the perimeter of my room that then goes up and powers my setup up here. So all the outlets in this room are dead except for one over there. And so as you see, this outlet is dead. There's nothing in it. I'll even demonstrate that by bringing a lamp near it and showing that it won't turn on. And then next I'll put the leads in this power bar, and you'll see that we have power. 113 volts AC, and that's just going into my bus bar up here. 113 volts AC. But I have to make the videos like this and this long to completely shut the trolls up and prove everything. And again, this outlet is dead. Completely. So, we're extracting ground power when the transmitter is on, as you can see. And for those who don't know, the ground connection of your electrical system is never shut off. It always goes to earth ground and utility ground. So I just showed that that outlet is completely dead. Next, I'll try and find a lamp to demonstrate it even more. I should have probably planned this a little more. I could show it with the glue gun, because when the glue gun's on, the back of it glows red. So as you see, it's on. I'll unplug it. So glue gun light is off. I plug the glue gun in up here. It comes on. As you see, the light is red. So glue gun plugged in up here, comes on. So there can be no doubt that this is a dead outlet. And then I plug it in here. It doesn't come on. It's a dead outlet. There's no light. And again, I'll plug it in up here. The light comes on. So I'm only using the ground of this outlet for earth energy extraction. Again, that's plugged in. No power, the glue gun's off. So that completely proves it. Next, I will show you. Put the glue gun away. Next, I will show you the power output of this circuit. And keep in mind, there's also the sparks emitted from the circuitry is also a bit of a strange color. I'm not sure if I can demonstrate it, but the sparks are almost like an aqua purple color. They're especially visible when you connect a motor to it, which is very interesting. And I know I need more room, and I suck at filming. Just been working a lot. I have a full-time job, and I also do the side business of selling these wireless power kits. And I'm writing a PDF booklet that will be anywhere from $5, $10, or $15. I haven't worked out the price yet. And it will fully detail and disclose how to build all these systems and the theory behind how they work and how you get excess power from them. There's those weird sparks. It's like a weird purpley blue color. Oh, the motor's getting caught. I'll try it over here. I really should have taped it down or something. Not sure if those sparks are showing. So watch when the motor runs. No load on the system. We consume 2.6 watts. I connect a load on the system. We go down to consuming like 2.4 watts. Yeah. How weird is that? And keep in mind, we're running a motor with wireless power from a receiver and the combined circuitry of a grounded bridge rectifier. And we still have wireless power. This is the part where it really blows your mind. And again, I'm going to take everything apart and show you everything. It's going to be a long video, maybe. I'm trying to go for under 40 minutes, so there can be no doubt of anything. So 2.4 watts. I'm trying to show those weird colored sparks that occur. I think it's the transmitter's giving off a new form of energy, but I could be wrong on that. There it is. There's those weird colored sparks. They're like a purpley blue. If I turn the transmitter up to about 3 or 5 watts, it's really visible. So anyway, that fell down. I'm going to disconnect everything and show you what's up. So I'll disconnect this board. And this board is now powering down. He's down here. He's not part of the system in any way at all. I'll set up my multimeter. Multimeter is here, and before I set that up, I'll show you the bridge rectifier circuit that literally is in line with my ground connection. And you see the power output just connects to the resonant receiver coil, which adds to it. So I'll show you the voltage output, and you have to bear with me because I'm doing this one-handed and everything fights me. So here is the output from the resonant receiver coil. Here is our voltage, 47 volts DC. We have an input to our transmitter of 24 volts, 112 milliamps, 2.6 watts. Now, what is our short circuit current? Our short circuit current overloads the meter. I'm going to have to lower this to where it reads. So as you see right here, we're inputting 20 volts to the transmitter, almost 21, at 90 milliamps, 1.872 watts. Our resonant receiver coil plus our grounded bridge rectifier, which is combined, has a combined output of 185 milliamps at 39 volts. Is this circuit right here not over unity? Are we not pulling excess power out of the earth? And for all those that say this is impossible, no, it isn't. We're creating a type of pumping effect, and you can even ask ChatGPT these questions, and it will tell you, yes, this can be done, and it's fully possible. So here's our short circuit current, 186 milliamps, while we have a voltage of 40 volts. Now keep in mind, I can literally now run a long wire. I can run a long wire from a ground connection there, or I can literally set up 2 big metal plates or 2 long lengths of wire, and in the middle I could add a bridge rectifier again, and there'll be power output from it, and I can just add the power output from that rectifier to the receiver coil, and it keeps stacking. Because when I added this grounded bridge rectifier, the power went from, I believe it went from 100 milliamps to like 180. So there was a gain of 80 milliamps in the system. So, now keep in mind, I'm dead shorting that, right? Keep in mind, I'm dead shorting that. And we still have wireless power. At less than 2 watts, that shouldn't even be possible. I'm dead shorting this connection, and it's saying we have 182 milliamps. And we still have impressive wireless power. That should be impossible. Very impressive wireless power. And again, I could run a wire, a long length of wire, from one piece of metal here, another piece of metal over here. In the middle, the bridge rectifier. AC side of bridge rectifier is in the middle of the wire. One side that way, one side that way. And we have a DC output. And then I could combine that with here, and I'd get even more power. I've done that. The setup gets messy. But we're at a stage now where we literally can get 3 to 5 times the output power And there's nothing pseudoscience or fake about that, and it's completely confirmed even with ChatGPT. We know how to do it. We're almost at that step. The only problem arises, how do we substitute the ground connection? Because the excess power comes from a heavy earth ground connection. So we're dead shorting that. 183 milliamps. And we still have output. Like, we have output to the point where it almost seems magical. We're creating a self-regenerative wireless power system. And you haven't even seen what it can do when I bring this baby up to 5 or 10 watts. It gets scary. The output of this becomes 1 or 2 amps at 50 to 60 volts DC and will blow you away. And these diodes are only rated for 1 amp continuous, and they will blow if I bring it up to 10 or 20 watts. So now I will connect the motor to the raw output. This board just impedance matched the bridge rectifier circuitry to make it a little more efficient, a little more power there. So I will now connect the motor to the raw output of the receiver without the impedance matched DC to DC converter board. So he runs. As you see, again, that effect still occurs when the load runs. The power input to the transmitter drops, which is a very interesting phenomenon. And we still got wireless power. Tube is lit. I'm going to shut the light off in my room so you can see that better. And this is why I call it like a magical system. Motor is going. Fluorescent tube is lit. All while the transmitter consumes 1.8 watts of power. And this is a very precise DC power supply. There can be no exceptions on its accuracy. There can be no questions on it, and I will shut it off soon to show that there's nothing secretly powering the system. The power supply is also plugged into a watt meter. And again, we still have impressive wireless power at 1.8 watts power consumption with no degradation of the system. Very impressive. And again, I could earth ground this, put a rectifier here, and I'd have output. I can take this, connect this to this light. The metal of this light, this type of radiant energy seems to accumulate on anything metal around the... And look how bright that is. That's phenomenal. That shouldn't even be possible. And again, I can touch this to the measuring tape, and it will light up. Very phenomenal effects. This measuring tape just sits here. We'll do a whole room tour. There's nothing under my desk. Nothing under my desks. No secret transmitter hidden anywhere. That's the one outlet in my room that works. From it, I have extension cords that branch out to power the rest of my room. That's the one working outlet in my room. It's a 15 amp 120 volt outlet. Motor is spinning away happily, and he's spinning away happily from the extracted ground power circuit combined with the resonant receiver circuit. And we still got wireless power. I'll turn my light back on so you can clearly see what's going on. I will shut the system off, and you will see that all effects will cease. I'll try and get this in frame. System is off, and the circuitry is so efficient it takes a couple seconds to shut off. We have no more wireless power effects. They have ceased. Nothing is occurring here. It is ceased. Again, I'll switch the system back on and you'll see that it all comes powering back up. There we go. So we will do a DC current reading again on this circuit, and then I'll begin to take it apart and show you everything how it's connected. 185 milliamps short circuit current. And a voltage of 39 volts DC. This output is more than double what it takes to run the transmitter. We have a power output of 184 milliamps with 40 volts DC, and when running heavy loads at this point in the circuit, our power consumption drops. How is that possible? There's something occurring here that doesn't quite add up with conventional electrical theory. The transmitter might be emitting a new form of energy, and it might be longitudinal. So anyway, I will disconnect this. I will show all parts of the circuitry now, so that way no one can be like, oh, something was hidden, I'm not sure on how something worked, and this just came disconnected. So, as you see, when the transmitter is on, if you have a bridge rectifier circuit going from two earth-ground connections in series, you will get power from it. This is just an antenna wire, which had a capacitive effect to the ground. As you see, here's one bridge rectifier circuit. The AC side connects to an antenna. The other side connected to my long wire that was capacitively coupled to the earth. So again, one bridge rectifier, one AC side of the bridge rectifier went to a metal antenna. And the DC output was combined to the resident receiver. I will now remove this circuit. This rectifier circuit is now removed. All additional rectifier circuits had their outputs combined on the receiver coil. And this is where my first rectifier circuit ran for the additional power. When the transmitter was on, this rectifier circuit came off the negative of the transmitter. One AC side went from an earth connection, and the other AC side of the rectifier went to the negative of the DC supply. So you can see that. This was just my resonant receiver coil. This is now the output. It will be less. The output now will be probably under unity from removing those rectifier circuits. So, I think I heard someone pull in. Hold on. Oh, it's just a package guy. Anyway, that's connected. I'll do a DC reading. So I will connect, and I remove two rectifier circuits now, and you'll see that the power levels are less. So we now only get 31 volts at 136 milliamps, 140. And keep a note, we're also consuming more power, which is interesting. And now again, I will remove this rectifier circuit from the system, and you will see us drop in current. See that? There's a cumulative effect. And this is literally where the rectifier circuit goes. This was literally the rectifier circuit. You can see it plain as day. It went from an earth ground connection to, that's why I have the wires green, which is the earth connection. Earth ground connection to the negative of the DC supply. And now I will reconnect it, and you will see that our current increases. I'm going to try and get this in frame. And boom, our current increased. So that explains that. There can be no doubt. And I'd like to give a thank you to all those who support this work. And it was overdue to make a long video explaining everything. And again, there's nothing fictitious here. We're at a point in the system where I can keep duplicating that circuit and get all the power I want in the system. The only problem that I foresee arising is the system might be stationary and require additional good ground connections or a metal sheet in the ground. So again, you can ask ChatGPT whether these type of self-sustaining regenerative wireless power systems are possible. It will absolutely say yes, it is. And the gain in power comes from multiple things. We're sucking power out of the earth. We have high Q components. We have negative resistance. We have very efficient high frequency Scotty rectifier diodes. We have a heavily modified Slayer circuit, and we have very high Q coils that are in series and bucking. The ball antenna is the most important. Everything in the system is the most important to create a system that is more than the sum of its parts. So that explains that. That shows everything. There's nothing under here. So again, as you see, if I touch the coil, it messes with the output. And again, I'd like to say thank you to everyone, and it's getting very interesting. And I think we're near even more breakthroughs. I have some more pulse receiver circuitry coming in. This one couldn't quite do what I wanted because the light on this glows so bright it just wastes energy. So we're gonna have, I'm probably gonna use something with a solar charge controller circuit for this. And oh man, the ideas are just racing through my head on this. So, and I'm also gonna get the new version of the transistor I use as well. I believe it's an MJL, I forgot the name, but it's an MJL something transistor that's more efficient than the TIP 35C. It's like the newer model. Higher gain, higher everything. And for those that don't know, this is just a heavily modified energy efficient Slayer exciter circuit running the transmitter. So yeah, that about shows everything. For those that doubt it, well, there can't be no doubt. You may not. For those that don't like it, that don't accept over unity energy, the original laws of thermodynamics only applied to closed mechanical systems, not to electricity. Electricity is a metaphysical phenomenon, and electricity is a hybrid entity of dielectricity and magnetism, along with a temporal component. And any device that combines those three things, dielectricity, magnetism, and a temporal component with respect to time, you will get a generator. So that explains that. If you doubt that, you're butting heads with the electrical masters that gave you your modern world. Nikola Tesla, Steinmetz, Heaviside, Maxwell. The gain in energy doesn't come from electricity itself. It comes from the conversion process, because we turn DC electricity into a high frequency oscillating magnetic resonant field. And the gain in power then comes when we convert that high frequency resonant magnetic field back to DC electricity. And we can also seem to suck power out of the ground. And again, you will not get any energy output unless you have these bridge rectifiers. You have to convert that power to DC, and you combine that DC is where you get the gain. So again, that explains it. Thank you all, and stay tuned. This video went on long enough.